So let's continue from the previous recorded video. So here you can see the alpha and beta is solid solution. So here you can see alpha here and beta is solid solution, means that there is no other component here, only alpha, 100% alpha, and here it's 100% beta. All of this region, okay, is 100% beta, and all of this region is 100% alpha. So AE and BE, AE and BE. What is this line? As I said before, this is the line of a liquidous line, where up to this point, okay, and up to this point, the liquid present, but below this point, there is another component exists. Okay, which is liquid and alpha and liquid and plus beta. So up to this point only, liquid present, liquidous region present. Okay, so we call it liquidous line. Okay, so AC, CD and BD is a solidus line. So where is AC? Here, AC, CD, where is CD? Here, CD, and BD. And BD here, BD. This is all a solidus line, where B here is all solid solution, right? It is solid solution, so it is a solid. It's already become solid. Okay, so this is the line where the solidus line begin. Okay, solidus line begin. So CF, where is the CF here? CF DG is a solvus line. Okay, this is a solvus line where it's already become solvent. Okay, solvus. So we call it solvus line. Okay, so here we want to know about binary eutectic system. When we call it binary, it has a two component. Eutectic means that it has a special composition that have minimum melting temperature. So here you can see that here is the eutectic point where they have a minimum melting temperature. Okay, yeah, there is binary eutectic system. Basically this phase diagram is a binary eutectic system because they have a two composition, which is copper and silver. Okay, two component, and that has a special composition with minimum melting temperature. This is a minimum melting temperature. So here, this is where copper silver system, they have three single phase region. Okay, three single phase region, where you can see there is a liquid, there is this alpha, they also have a beta. Okay, there is three phase region. So what else the information that we can get from this graph? They have limited solubility. Okay, they have limited solubility, means that here alpha here is mostly copper, because as you go from this side, there will be more silver. So here is 100% copper, this is 100% silver at this point. So at 100% copper, so basically here will be the region of copper. So alpha here means that it is copper, because it is in the region of 100% copper. Okay, so it is mostly copper. So beta here, because it is in 100% silver, it of course has mostly silver. Okay, mostly silver. So TE, where's TE? Where's TE here? Where is TE? Here is a TE, where T equilibrium. Okay, TE is the temperature of equilibrium, where no liquid below TE. If you can see this point, is there any liquid here? No liquid. Above this point, they have a liquid. Okay, so below this point, there is no liquid. Okay, so at CE, where CE? CE is here as well, where T is a temperature and C is a composition. What is the composition here? Okay, composition at equilibrium. So you'll see that you make a line below, you'll see that the composition is around 71.9 of silver, and the remaining is copper. So that is how you read this phase diagram. So the eutectic reaction is like this. The liquid is transformed to alpha and beta, plus beta. Okay, so this is the equilibrium, or the reaction of the eutectic. Okay, so now we want to determine the phase and phase composition. It's the same as binary isomorphous system. So how you determine the weight fraction? The same. So you want to know, for example, they put the point here. Okay, they put the point here. So you the point here located at liquid plus beta region. So what is the percentage of liquid and what is the percentage of beta? Okay, what you will do is you have to make a tie line. Okay, tie line that connect this point to the liquidus line. Okay, this is liquidus line, and the other side connect to the solidus line. Okay, so what you're gonna do is you have to find, if you want to find what is the percentage of beta here, so you have to calculate R over R plus Q. If you want this point, okay, this composition, Q is over R plus Q. So this is how you calculate a weight fraction. Okay, now example. This is plumbum tin eutectic system. So how you know that this is a eutectic system? Because there is a minimum melting point here. Okay, so for a 40% tin and 60% plumbum alloy at 150, so this is basically the equation that will come up from in your exam. They will give you a point where you have to locate that point. So 40% tin and 60% plumbum. So where is 40% and 60% plumbum? So basically it is here, this point. Okay, this point at 150 here, at 150. So this is the point. Yeah, you got a point already. So what is the phase present? So the phase present here, okay, is alpha and beta, alpha plus beta. So this point located at alpha plus beta region. So the answer is alpha plus beta. So you got everything like 3 marks here already. So now they will ask you what is the phase composition. Easy, you have to make a tie line. Tie line that connect this point to the liquidus point. So I think the solvus line, solvus line here, and this point to the other part. Okay, so what you're gonna do next here is they want the phase composition. So now you have to make a line below. So here the Ca is 11% tin, and here Cb is 99. Is it? Okay, 99% of tin, right? So that is the phase composition. Okay, what is the relative amount of each phase? Now you have to calculate the amount. Okay, now you have to make a tie line. Okay, just now you just have to know the composition. What is the composition of Ca and Cb? Now you have to know the relative. The third question is the relative amount of each phase. So what you're gonna do is to get R and to get S. So to get R, so you have to know the value of S, which is Cb minus Co over Cb plus Ca minus Ca. Okay, so Cb minus Co, 99 minus 40 over 99 minus 11. So you will get the value of R. Okay, R, which is here, alpha. Okay, alpha, because we want to know what is the percentage of alpha and beta, right? So alpha is on the left side and beta on the right side. So now you want to know the percentage of amount of beta. Amount of beta is R over R plus S. So R here is 40 minus 11 over 99 minus 11. So you got the composition. Now you already get, like, I think around 15 marks or 10 basically, okay, for the second question or the third question of the final exam. So basically they will ask you about this. Okay, next, yeah, the same, like this is the example, you have to try by yourself. This is the microstructure, on how the microstructure change with the temperature. When you're cooling down the temperature at certain composition, what will be the microstructure? Okay, this question also familiar in the final exam. They want to know what will be the microstructure when you cool it down. Okay, so you don't have to remember, you just have to understand when they said that what happened to the alloy, the microstructure of the alloy at the 2% of tin. So you make a tie line, you make a line below at 2% of tin here. You make a line, so this line will touch and on every temperature. So you'll see that, okay, at this temperature all liquid, so all liquid, there is no crystalline, no crystal that appeared here, because there is all liquid at 380 something here. So when it cooled down here, now it's already touched the liquidous line. So when it touched liquidous line, okay, the alloy will start to form a crystal. So when it forms a crystal, there will be, there is alpha here, so there is a crystalline of alpha. So you make a simple dot here, that and you put a notice here that there is alpha. Okay, now you go down there, you cool it down, and you found that, this is all alpha, means that this alloy already solidified, there is no liquid anymore, okay, at this region. Okay, so no liquid, there's only a line. The crystal already become bigger. Okay, the crystal become bigger, so there is a line. We call it grain. Okay, and now it's already become solid. Okay, when you cool it down, of course it already become solid, right? So nothing happened, so everything become alpha. And here, if okay, there's not touch anything at this region, so nothing happened. So what happened if you cooling down at 18.3%? So you go to 18.3, so this is the point. So you make a line. Okay, you make a line, and the same, you got the same the similar microstructure, but here the difference is here, because it touch the alpha, it's in the location of alpha and beta region. So what happened to the microstructure at the alpha and beta region? So here, you know that, yeah, the alpha, they have this microstructure. There's nothing. The grain become bigger and already have only have alpha. But here they have beta. So okay, beta is also solid. So I have to make a dot here where the solid is embedded. The solid is precipitate in in this alloy. Means that the alloy is the alloy is now rich. Yeah, it's rich, kaya. Okay, it's rich in other composition. That composition is not soluble in alpha. Okay, like you put a sugar in I don't know, there is both solid that you cannot mix it together. Okay, so there is some precipitate that